Right, we're going to look at transformations, but first of all, you kind of have to get used to what graphs look like, okay? All these functions. So the identity function, y equals x, there's the straight line graph, okay? Slope of 1. The squared function, okay, there it is. Square root function, cube function, what if we go down here? Cube root function, reciprocal function, and absolute value function, okay? So you kind of get used to what they look like. There they all are. Have a good look at those. All right? Now, we're going to transform them. We're going to move them. All right? Here we go. Now then, supposing I have a graph. Here it is. This is it here. 1/5 x to the 4th. There it is. There's the graph. If all of a sudden I do 1/5 x to the 4th plus 5, I'm going to move it up 5. Hence, it'll go through here. See? 5. There you go. That's 5. If I have a 5th x to the 4th minus 3, I'll have this here. Okay, and again, minus 3, there it is, down at minus 3, cut through the y-axis. Okay, so that's just vertical translations, okay, up and down. So, plus 5, minus 3, there it is. That's fairly logical. Take the graph, move it up 5, take the graph, move it down 3. Okay, how about horizontal? Not quite as logical. Right, so, here we go. Here's the graph of, here's that 1/5 x 4th again. Now then, if I do 1/5 x minus 3 to the 4th, and notice, okay, so here's 1,000 minus 3, okay, there we go. But this is kind of just tagged on at the end, okay, it's 1/5 x to the 4th minus 3. But here, the minus 3 is kind of part of it, right there, okay, you just put the minus 3 inside the parenthesis. So, this is now the left and right movement. Now this, minus 3, so if you think about it, if this was the original origin, am I going minus 3? No, you're going this way, okay? You're moving to the plus 3 direction. So not quite as logical, but if you put it in your calculator, graph it, do some points, you'd see it will move here. So it's moved right 3, okay? So there you go. Now then, 1/5 x plus 7, this is now moved 7 to the left, okay? So again, left and right movement. You've got to figure out, okay, right, 1/5 x to the minus 3 to the power 4th, okay, I moved it 3 to the right. 1/5 x plus 7 to the power 4th, I moved it 7 to the left, okay? So that is the horizontal translation. Let's look at some examples. Okay, x squared minus 6. Well, surely I'm taking the x squared graph and moving it down 6. That's fairly straightforward, and there it is. I moved it down 6. From there, it went down to there. Same graph, moved down 6. How about this one? Now, if I do a quick, right, I know the absolute, remember, we need to know what these look like. I'm doing this one. So, the absolute graph is that V shape, okay? If here's the axes, I'm going to move it 4 where? Minus 4, so move it in the plus direction 4. So if I go like, say, 1, 2, 3, 4, it would now look like this, okay? There we go. It's not just x, absolute x with a minus 4 tagged on at the end, where you move it down 4, okay? It's part of the absolute. So let's have a look. There it is, okay? There it is. I moved it 4 to the right. More examples. This one, well, okay, if this is what the normal root x graph looks like, okay, again, go back here, where are we, there it is, okay, well, can you see, I'm going to move it, where am I going to move it, 2 to the left, okay, 2 to the left, so that will be, and there it is, okay, I moved it 2 to the left, so there's the graph of root x plus 2, okay, again, if it was just root x with a plus 2 tagged on at the end, I'd move it up 2, okay? But it's not. It's part of the root is that plus 2, okay? It's the left and right movement. What else do we have? 2 movements. Right. Plus 2, okay? Means I'm going to move it 2 to the left. And then can you see? Down 3. So I would go down 1, 2, 3, and something like that. Let's have a look. Okay, where is it? There it is. Okay, so again, I moved it 1, 2 to the left, down 1, 2, 3, and there it is. Okay.